Okay, welcome again. In the previous video, we had these two examples, 5 digits, 11100, and then we have 8 digits, 11 and 6 zeros, and we converted them to decimal, then we put them back to binary. And now I just want to show you, and because we're coming to a point where we understand little by little how IP version 4 is set up. It contains 4 octets, and those octets are 8 bits. Every 8 bit can either be 1 and 0, so we're getting there. If you see the IP address such as 192.168.1.0, this is a decimal notation of IP version 4, but actually there are binary numbers, so 192 will be this number here, so 11000000, and then 168 is going to be another number, 1 is going to be another number, 0 is going to be another number. So I want to show you how IP address is constructed, but let's take another example, maybe 168. So if we have another window, or this number, let's call it example number 3, because we've done 1 and 2 and 3. And so we have the number 10101, 10101, and then we put, the rest would be zeros. Okay, let's compare this number from binary to decimal. Again, the steps are cross the first number, put a bracket here, and put the number there, then multiply by 2. Then digits left will be our power. So 1, 2, 3, 4, 5, 6, 7. Then we have a 7 there. Then plus, we cross that number, 0 times 2 to the power of, how many digits left there? Now 6. You count 1, 2, 3, 4, 5, 6. And then plus, you have another number, cross it first, write it down, 1 times 2 to the power of, and then you have 5 left there. Then plus, you cross this number, put it here, 2 to the power of, you've got 4 there. And then we continue and cross that number, let's put it here, 1 times 2 to the power of 3. And then plus, cross this number, 0 times 2 to the power of 2. And then plus, cross this number, it's a 0 to the power of 1, because only 1 digit left here. And then plus, we cross the 0, write it down here, 2 to the power. The power is how many digits are left? Nothing. So we put 0 there. Now we do the bit mask formula process. Let's say brackets first, index, and then division, multiplication, addition, and subtraction. We start with the first number. It's in a bracket. We start whatever is in the bracket, and then we see what's in the bracket. So brackets done, index. We see there's times and index. So we keep the times. We don't touch it yet. But 2 to the power of 7 is 2 multiplied by 7 times. 2 times 2, 4, 5, 6, 7. So you multiply this 2, gives you 4. If you multiply this 2 by 2 by 2, it is this 2 by 2, 4 by 2, 8. And then if you do continue, it becomes 16, and it becomes 32, then it becomes 64. And then the last one gives you 128. So we know 7 times will give us 128, and we plus bracket again, the 0 here, there's a multiplication, we keep it, 2 to the power of 6, 6 times gives you 64, so you have 64 there. Then we have this number 1. Don't forget the numbers you have here, they are very important, because later when you multiply by another number by 0, it's going to be 0. If you forget and put 1 here instead of writing that 0, then you get a wrong calculation. So just make sure these are clear. We are now at here, and then 2 to the power of 5, that's 32. Then plus another bracket, we have 0 and 2 to the power of 4, which is 16. And then plus, let's put it here, 1 times 2 to the power of 3 is 8. And then plus 1 times 0 here, time 2 times 2 to the power of 2, that means 4. And then 0 there, we write it down, 2 to the power of 1 is 2, and the last one, it is 0 times 2 to the power of 0, it's 1. So any number to the power of 0, it's again 1. So 1 times 128, that gives you 128. And then 0 times 64 is 60. Then 1 times 32, it is 32 here. And then plus, and that is 0 there, 0 times 16. And then if you add 1 times 8, it's 8 again. And then 0 times 4, 0 there, 0 times 2, 0, 0 times 1, 0. So 128 plus 32 plus 8. So put them together if you cannot remember. 128, 32, and 8. So this is 18. 8 plus 2, 10 plus 8, 18. You carry 1, add here 3. 3 plus 3, 6. And then bring that one down, 168. So 168, if you put it back to binary, and if you put the 168 here, divide by 2, this is 8, 4, and then you're left with no number because they're divided into equal parts, even number. And if you divide this by 2, this gives you 4, 2, and again no number. This gives you 21, there's no remainder again. Here you get 10 and 10, but you have 1 left, so you carry it as a remainder. The 10 gives you 5 and 5, nothing's left. The 5 gives you 2 and 2, but you'll be left with 1. 2 gives you 1 and 1, there will be nothing left, but the 1 left there, you carry it over because it doesn't divide. So this number, if you now read it from bottom up, it gives you 1, 0, 1, 0, 1, and then 3 zeros after that. That's the number we get there. And this number is 168. If you check the number we had previously, it was 1, 1, and 6 zeros. That gave us 192, isn't it? Here. And if we now check the 1, 0, 1, 0, 1, and 3 zeros, that's giving us 168. So we can say actually 1, 1, 0, 0, 0, 0, 0, 0, which is from the previous one, which is here. That number is 192. But if we check the second number here, and we put 1, 0, 1, 0, 1, and then 3 zeros, this is actually in decimals 192, 168. And if we have 0, 0, 0, 0, 0, 0, 0, 1, that's dot 1. And if we have, let's say, 4, it's going to be 0, 0, 0, 0, and then 0, 1, 0, 1. That's this is 5. So we put dot 5. That's an IP address. And if you see now the writing, we are putting it in a way that we are dividing 4 groups into 8 bits. So 8 bits here, 8 bits here, 8 bits here, 8 bits here. But as a human to read these numbers easily, we need them decimal notation. That's why you always see IP addresses this way. So what is IP address then? IP address, there are 2 types. The Internet Protocol address, 2 types, IP version 4 and IP version 6. We will record another clip to discuss that, but just to give you a heads up for that, if you divide X and X and X and X, these are 4, and if each one is 8 bits, it can only be 1s and 0s. If you have them 1, 1, 1, 1, 4, 1, 1, 1, 1, and then 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. That gives you, without the dot at the end, so you have 8 bits here and 8 bits here. So 8 bits here, 8 bits here, 8 bits here, 8 bits here. If you combine them all, this gives you 32. That's the 32 bits you always hear when it comes to IP version 4. For IP, this is IPv4. For IP version 6, when it comes to IP version 6, we have a larger number, which is 128. That 128, it's if you power to the power of that number, it gives you a huge number. That's the number of IP addresses we can get. And when it comes to IP version 4, we have 2 to the power of 32. That number is much less than 2 to the power of 128. Since that number is small, and some IP addresses are used for routing traffic over the internet or a public IP address, then it's a limitation of how much that could be available to us. So then came what we call subnetting, what we call netting, just to conserve the IP addresses. We'll discuss that separately. Thank you for your time.